Hello and welcome. My name is Matthew Hawes, and I am a data scientist with the University of Minnesota Foundation. I'm making this presentation for App4Bytes, primarily directed at prospect researchers and others who are maybe unfamiliar with R and how they might leverage it in their work. I'm thinking maybe you have some experience in Excel, but would like to move on to something a little more advanced. And so I'd like to introduce you to the R data table package specifically. And so I'll begin by sharing my screen. I'm going to open up RStudio. So RStudio is an integrated development environment for the R language. I do assume for this presentation that you already have both R and RStudio installed on your machine. If you do not, you can pause this video and go online and download both to your machine. You'll need both for this tutorial, and there is a wealth of resources online with instructions for how to do that. So once you've installed R and RStudio, we're going to first begin by going through how you download packages to make your R experience even better. So the main purpose of this tutorial, like I said, is to use the data table R package. It does not come standard with R, and so the way you install packages is by typing install.packages. All functions in R require parentheses, and the install.packages also requires quotation marks around the name of the package that you want to install. So in this case, you'd want to type exactly what you see. I'm not going to hit enter because I already have it installed and don't want to take the time to reinstall it. But once that's done, you should get the caret symbol back that tells you that R is ready for your next command. And then you could type stringer and hit enter again. And once that is done, we begin by loading them. So every time you start a new R session, you need to load the package that you intend to use. So we will first start with loading data table. You do not need the quotation marks in this instance. And so it gives us a little message, but we don't need to worry about that. We also want to install stringer. Stringer is necessary for a specific string substitute function that we'll be using in this tutorial. It gives us a warning, but this is pretty unimportant for us, so we're just going to ignore it. Now, to see where you are in your computer system, you can use the get working directory function. You don't need to put in any commands or any arguments for this one. And it looks like we're already in the Appr tutorial directory or folder that I've made for this video. So we don't need to worry about this set working directory function. But if you wanted to change directories, you could use the set working directory function in order to switch to a different directory. Now we have a movie data set, the movie lens data set that I pulled from Kaggle. They're stored separately in CSV files. CSV stands for comma separated value. And this is something that you might commonly open in Excel. So the fread function is a pretty powerful function, and it's from the data table package that you can use to read in CSV files, and we're going to save the data into an object. This one will be called movies, and this is a data table object. So it'll look organized in a similar way as you would see in Excel. And I'll just show you a quick preview of that. So you can see there's a column called movie ID. This is basically a key. So if you're familiar with SQL, this is how you might combine one data table with a different data table. We also have a column called title. And you can see there's a movie in each row as well as the year that it was released, as well as a column called genres, with all the genres that movie belongs to. There's another file we're going to load. It's called ratings. And this is a little bit bigger, so it'll take a couple more seconds than the movies data set did. And that's primarily because I think each movie has multiple ratings because multiple individuals gave ratings for each movie. So we can just be grateful that there is a progress bar. It won't take, too long, and we'll get a caret with a cursor indicating that it's ready for next command, and it's already done. So now we can preview that column as well. So you can see there's a column called user ID. So each user ID corresponds to a different user who's left a rating for a movie, as well as a movie ID that corresponds to a movie from the movies data table, the rating that the user left, as well as a timestamp. And the timestamp is pretty unimportant for our purposes, but I'll get to that later. So going back to the movies data set, you can see that there's no column called year. The year data is contained within the parentheses in the title column. So I would like to fix that. So we're going to use two things here that I want to draw your attention to. This operator with a colon and the equal sign is data table specific, and that's how you can create a new column in your data table. The name that you give it is immediately to the left of that operator. We're calling this one year. And we're using the string substitute function that we got from the stringer R package. And what we're feeding it is the title column, and then using this start argument to take the last 6 characters of each title. And so it's basically like a cell that we're looking at one at a time, but R does this really quickly. So if we type movies again, you can see the title column is exactly as it was before, but now we have a column called year, and it has the last 6 characters from that title column. Now, we want to get rid of those parentheses because they're not necessary, and they're a little messy, in my opinion. So, again, we're using that data table operator for creating a new column to edit that column. And we're using the gsub function to do basically a search and replace that you might have done in Excel before. Those 2 backslashes, those are simply escape characters that tells R to take that opening parentheses literally, and then we're replacing it in the second argument with nothing. That is not even a blank space. So we carry that out, as well as the same command for the closing parentheses, and we can type movies again. And now you can see that the year column is much cleaner. I also, before moving on, just want to clean up the title column. So we're going to use the same principle that we did to clean up the year column, and we're going to just get rid of that year trailing the name of the movie. This is a regular expression that we are using. That $sign indicates that it's the end of the string. So we're going to include everything up until the last 7 characters, and it's 7 characters so that we account for the space between the end of the movie and the year. And we look at the data table again, and now we can see that it's been cleaned up quite nicely. And now we can do things like filter the data based on the year. So let's say we want to look at all movies that were released in 2005. We use the column name, in this case year, as well as 2 equal signs that basically we're telling R we want all rows where this statement is true. And we get 649 rows where the year is 2005. So all 649 of these movies were released in 2005. We can also search for genres that are comedies. So the year 2005, that's like a numeric data type, and now we're looking at string data types, so characters, in other words. And what you'll notice here is that we only get genres where the only genre is comedy. But we know that there's lots of other movies where there were multiple genres, including comedy. And those were not included in this filter because it only took that literally. So only instances in the genres column where comedy is the only thing seen is what is returned here. But we can use the grepl function in order to find all rows where comedy occurs, whether or not there are other genres as well. Now we can see we have 6,622 rows where the genre contains comedy, but it's not necessarily the only genre. It's also possible to filter based on multiple criteria. So I'm going to filter based on whether or not comedy is in the genre column, as well as released in 2005. So we should get films that meet both conditions, where genre has comedy in the column, as well as were released in 2005. And we are left with 211 rows that were released in 2005 where comedy occurs in the genres column. Now, earlier I said we wanted to come back to that timestamp column in the ratings data set. So you can also use that operator with a colon and the equal sign to remove columns that you don't need anymore. So we're defining the timestamp column with its operator as well as the word null. What this is going to do is it's going to remove that column. And if we type ratings again, you can indeed see that this has been true. Now, I'd like to merge the movies and ratings data tables so that we can work with them together. And as I said earlier in this talk, we're going to use movie ID to combine the two data tables. And we're going to save them to an object called merge. Now, this might take a couple of seconds, so while we're waiting, I can maybe talk about a few other aspects to this function. If we did not save to an object, which is what the arrow symbol does, so this arrow is a common way of assigning output to an object. It's the less than sign followed by the hyphen. If we didn't include that, it would simply print to the screen and you wouldn't have it saved to work with or manipulate later. But now that it's done, it's saved as the merged object. You can see in the upper right-hand side, all of the objects I've been saving, they appear there for your convenience. Now if we type merged, it should print to the screen. And we can see they have been merged. So we have a column called movie ID, title, the genres of that movie, year it was released, user ID, as well as the rating. So if we wanted to, we could plot the movies based on genres or rating. There's a lot of things we could do, but I'm sort of running short on time, so I won't be doing that today. But just to close out, I will show you that we can sort data. So I use the order function within the merge data table and using negative rating, minus rating to make it in a certain order. So you can define whether you want ascending or descending with that minus sign. And I'll just wait until this is finished. It should, okay, it's already done. So it's in descending order. So you can see that minus sign sorted in descending order. The default is ascending order. So if you did not include the minus sign, it would start with 0.5, the lowest rating possible. Anyway, I hope this has been helpful. Thank you for your time, and happy computing.